Welcome to today's class. We'll be talking about the derivatives of a logarithmic function. And before I talk about how to find the differentiation of y when you're given a logarithmic function, now whenever you hear the word logarithmic function, you're talking about log, or you can see it in this form, ln. So this is what we call the natural logarithm, the ln. Now, whenever you're talking about how to make that solve for the derivative of a function carrying a logarithm, or either is it in this way, I would like to first of all point out some basic rules in solving logarithmic functions. Now, let's talk about the first rule. If you have a ln x y, that's you're having a function x multiplying a function y, then according to the rules of logarithm, this can be broken down to what? Ln x plus ln y. Now this is assuming that we have there's one particular base. Let's call the base a particular a. So that means the base is the same thing for here, the same thing for here. But since I'm using my natural logarithm doesn't have a base. All the bases are is just one particular base, which is the normal common base. So here is our ln x and here's our ln y. Okay, and then next, if we have ln x dividing y, then it can be broken down to what? Ln x minus ln y. Now this is very, very important, what I'm doing right now, because it will help us to be able to simplify our working when we are given a logarithmic function to work with. And then also, if we have our ln x raised to the power of y, then we can write this as what? Y multiplying ln xy. That's how multiplying ln x. So y multiplying, so this is multiplying ln x. And basically this would be the three functions, the three rules. There are still many more rules in logarithm, but I think we'll keep it down to these three rules because most of what you'll be working with will not exceed these three rules. And okay, so let's pick questions. Before I do that, let me talk about the derivative of a logarithmic function. Now, whenever I have given your y is equal to ln x, then if they actually find your dy dx, your dy dx is equal to 1 over x. Now, this is actually formed by saying if our y, let me break this down again. If it's actually formed by saying taking your derivative of your x over just the function of x. So what does it mean? It means that what is my function of x? My function of x in this case, remember this is my ln. My function of x in this case is what? X, right? So if I have f of x in this particular question, it will be equal to what? X here. Then what is my derivative of x is equal to 1. That's why we have 1 here, because when we found the derivative, it just gives us 1, and then put back the function of x, and that's what we did here, put back the function of x. So let's take something again. If we have our y to be equal to, let's call it ln 3x, let's call it ln 3x. Then what again do? We know that our function of x is equal to 3x, and our derivative of x is equal to what? 3, right? Because when you find the differentiation of 3x, we get 3. Therefore, our dy dx, which is equal to f of x, that's the derivative of f of x, and f of x divided by f of x will be equal to what? 3 over 3x. So we can cancel out 3 here, and what do we have? 1 over x. So let's take one more question before we start taking more complex ones. What if we're given this one? Let's say we're given y is equal to ln 1 minus 3x. Then we know that our f of x again is equal to what? 1 minus 3x. And then our f prime of x, that's our derivative of f of x, will be giving us what? So will be giving us what? Remember, this one is a constant, so it comes to 0, and then minus 3x will give us what? Just minus 3. So therefore, we know that our dy dx will be giving us the derivative of f of x over the function of x is equal to, what's the derivative? We have minus 3 over what? 1 minus 3x, and this is the final answer. So that's how you solve for ln. This is just a very simple way of solving it. You can pause this video. The next video we'll be coming back to will be where we'll be taking more extensive or extended solving using the logarithmic function. Okay.